All right, so we're getting into section 6H.2, and this is proving proofs by contradiction. Proofs by contradiction. All right, it sounds a little counterintuitive, right? But by the end of the day, you should be able to prove by contradiction to justify that circles are similar. So what is a proof by contradiction? So proof by contradiction is, well, if I say, it's like saying something that I kind of know is not true, right? And then using known postulates, theorems, or rules to lead to a conclusion that contradicts my initial statement, right? So let's kind of show something that's not circle related to kind of prove what we're saying, what we're going to here. Okay, let's say that I'm trying to prove that I cannot have two obtuse angles in a triangle. Okay, I know I can't have two obtuse angles in a triangle, but someone's like, yeah, you can absolutely have two obtuse triangles in a triangle. Two obtuse angles in a triangle. And then I'm like, okay, well, if what you're saying is true, I'm like, okay, well, an obtuse triangle, and we'll say we have a triangle, okay? I'm trying to explain it to somebody. And I'm like, all right, here, let me draw it for you. Let's go. Let me prove it to you that we can't have two obtuse angles in a triangle. All right. So here we go. Here's my triangle. Okay. This is my triangle. It's not quite, it's just my triangle, right? This is my triangle. Let's say that this is angle A. This is angle B, and this is angle C. Okay. And what is an obtuse angle, right? An obtuse angle. The definition of an obtuse angle is an angle that is greater than, an angle greater than 90 degrees, right? And I'm like, you agree with that definition? And they're like, yeah, that is definitely what an obtuse angle is. And he was like, okay. I'm like, okay, are you sure you still think you can have two triangles with, a triangle? Are you sure you can still have two angles in a triangle greater than 90 degrees? And he's like, yeah. I'm like, okay, well, let's keep going with this. All right. So I'm like, all right, well, here we go. So let's say, and I know that my thumb rule is that the interior angles of a triangle equal 180 degrees. And I'm like, that's a theory that I know, or that's not a theory. That's a well-known postulate, right? That is a well-known thing, that the interior angles of a triangle must equal 180 degrees, right? So say, for instance, that I have angle A is greater than 90 degrees, and angle B is greater than 90 degrees, right? So angle A plus angle B equals something greater than 90 degrees plus something greater than 90 degrees, right? So therefore, the sum of those is greater than 180 degrees. So therefore, angle C, so the sum of these interior angles, so angle A plus angle B plus angle C must equal 180 degrees, right? And if angle A and B is greater than 180 degrees, and I solve for angle C, right, I'm going to have to go plus angle C equals 180 degrees. I move this over here, right? Angle C is going to have to equal to, it's something greater than 100, it's going to be 180 degrees minus something greater than 180 degrees. That means that angle C, that means that angle C is going to be, angle C is going to be like less than 0, right, degrees, right? So that can't be a thing, right? I can't have it in a triangle. I can't have an angle that is negative degrees, right? That is impossible. That is contradicts, this angle C contradicts this here, the sum of the interior angles of a triangle, right? So because this is a contradictory statement, it disproves that I can have two obtuse angles. I can have two obtuse angles in a triangle. Okay, so let's do this to prove two triangles or two circles. Right? Let's do this to prove that two triangles are similar, or two circles are similar. All right, you know that all circles are similar from the last lesson. All right, but let's say that I have a circle. I found a way to make similar circles now, I'm happy to say. Right, and let's say that I have this circle, and we're going to call it my green circle. I'm going to go, how did I do this? So yeah, I got to go right here, and then I got to rotate it like this. Okay, here we go. That is my circle-ish. Okay, this is my circle, and this is my green circle. This is my center point. Okay, and this is my radius is 4. Radius equals 4. Okay, and then I have another circle, and we'll say it's my blue circle, and we'll go. Let's see, one. We'll go right here. Why not? I don't know what it's going to be, but I'm sure it'll work out. I rotated the wrong thing. Rotate. What am I doing? Rotate this, I guess. What am I doing? Okay, I gotta put this here, and I'm gonna rotate this. That didn't turn out too bad. All right, so I have this one here, and this one's radius is 2. Okay, so I'm going to figure out two things about these two circles. I'm going to, first I have to say that, I'm going to assume that we'll solve the circle G, and we'll call the circle B because it's circle blue and circle green. We're going to assume, step 1, we're going to assume that circle green is not, let me get a different color. assume that circle green is not similar to circle blue. Okay. Because all right, so because by definition, right, in order for these two things to be similar, right, they would have to have dilated, right? And if they dilated, they would have to have a similar, some similar property. The only thing, the things that we could compare are the radius, the diameter, and the circumference. Okay, so let's compare those. All right, so let's compare. Let us compare the radius and circumference. All right, so we know that the circumference equals 2 pi r. All right, so let's look at the ratio. This is my image, and this is my pre-image. Okay, so we'll be like, all right, so this was dilated to this, and we'll see if, and we'll try to say that, and we'll see if they're similar or not using that, right? So, so if they were similar, then the ratio of the diameter to the circle would be the same. I'll pause for a second while I go get some. All right, so let's compare the radius of one to the radius of the other. So the scale factor. So in order for these to not be similar, the two scale factors that we're going to calculate would have to not be the same. Okay, so we're going to have to say like something along the lines of the ratio to the ratio of the circumference of R to G is what we should do. It's not R to G. What am I doing? A ratio of the circumference. Well, let's do the radius of the radius of circle B to circle G is, so pre-image is the after. Let's do G to B. Do circle G to B is 4 divided by 2 equals 2. 3. The ratio of the circumference of G to B is, it's going to be 2 times pi times 4 divided by, because that's the equation for circumference, divided by 2 times pi times 2. 2 pi r, 2 pi r, 2 pi r equals, all right, so we got 2 times pi times 4 equals 25.1-ish, 25.133. That's in the wrong color. 25.133 divided by 2 pi 2. And actually I can just like cancel those out, and it's going to be equal to 2 pi's cancel out. It's going to be equal to 4 over 2, which equals 2. And that equals 2 on the calculator as well. All right, and then now since you can say 3 or 4, since both the ratio of the circumferences and radii, I don't know how to spell radii, right, are the same, or are proportional circles G and B are similar. All right, the scale factor is the same for every measurable part. Scale factor is the same for every measurable part, right? Therefore, similarity is a thing. Right? There are no angles to measure, right? But the distance between each point on the circumference, is the same as r, right? So I guess there are angles to measure, like of here, of the center point, but like there's no angles in the circumference, or it's just a smooth circle, right? So since this contradicts this statement, this assumption, the assumption statement it's not true. It's not true. The assumption statement is false. Right? We proved it was false with math, right? With known postulates and theorems. Therefore, we can say all circles are similar. All right? So there you go. So that's how you do it. Pretty quick lesson. But this is just how you're using math. You state something that you're trying to prove is false or true, right? You know that these are similar. You're trying to prove that it's true, so you say the opposite is true, and then you use math. You come up with your contradictory statement, right? And the contradictory statement, makes that, and then it helps you prove that those are true. That is false. That proves that what you want to be true is true. Okay, hope that helps out.